Now, next one is what? Here we have S1, S2. This is S1 and this is S2. These two are meeting at point Q. Now think that there are 7 wavelengths like this, and there are 9 wavelengths. 7, this is 7 lambda, and this is 9 lambda. 9 wavelengths are there, and 7 wavelengths are there. Now here what happens? That means what? S2Q minus S1Q equal to 2 lambda. Now we have the formula y1 is equal to A cos omega t. Y2 is equal to A cos omega t minus 4 pi. 2 lambda means 4. Now, this can be written as what? This can be written as Y2 is equal to what? A cos omega. A cos omega. Okay, so why? Because this is 4 pi. Cos 360 minus theta is cos theta only. Again, they went in phase. Even though this is 7 lambda, this is 9 lambda, then also they went in phase. Okay, is that clear? There in before case, exactly same lambdas. Means 5 lambda, no problem. Exactly it was same. But here after doing this also we got the same again. Okay, they are still in, again, they are in phase. Okay, they are in phase. Next example, one more example, that is like suppose there are again 2 cases. One is S1, one is S2. They both are meeting like this. This is at point R. Here it is 9.75 lambda. And this one is 7.25 lambda. 9.75 lambda and 7.25 lambda. Here we take S2R minus S1R is equal to minus 2.5 lambda. Okay, it is 2.5 lambda. So what will happen now? Y1 is equal to A cos omega t. And Y2 is equal to what? Y2 is equal to A cos omega t plus 5 pi. Omega t plus 5 pi. Now, so when it is, it's not exactly 360. It is 4 pi c here. 4 will become 4 pi. Sorry. See, 1 lambda is equal to 2 pi. 2 lambda means 4 pi. 2.5 lambda means 5 pi. So this is how much? 360 degrees. This is 720 degrees. Means 1 complete rotation. This is more than that. Means how can we write 360? Means it is 0 degrees again. This is also 0 degrees again. But this is 180 degrees. Okay. Is that clear? 180 degrees means 180 degrees plus theta will become minus cos theta. So this will become minus A cos theta, minus A cos omega t. So this is positive A cos omega t. This is minus A cos omega t. So what will happen? When we add both of them, it will become what? It will become 0. Okay. So this will become y1 plus y2 will become 0. Is that clear? Y1 here, y1 plus y2 will become equal to 0. That means it is destructive, or we can say out of phase. They both were out of phase. It will give rise to a dark fringe. This will give rise to bright fringe. If they are in phase, it will give rise to bright fringe, and this will give rise to dark fringe. Understood? This will give rise to.
So what does that mean?
Dark line, bright line. That's the meaning.
Of a light, right?
Yeah, of light. Bright light and dark light you will get. Okay.
But then, sir, how can 2 lights or 2 wavelengths give a dark light?
Means if they meet in phase, if they meet like this in phase, it will give rise to bright. You know the superposition, right? Because of the superposition.
Yes,
of the Understood?
Yes, sir. But then I don't understand the fact that when 2 lights meet together, how can it become dark?
Dark means out of phase. Out of phase means if the first one is meeting in this way and the second one is meeting in this way.
Oh, okay. So they cancel out each other.
This is like a destructive superposition. Understood now?
Yes, sir. Now I got it.
You got it now? Yeah. So this comes under constructive. This comes under destructive interference. Now we will go with the
Sir,
phase.
is there any,
Yeah.
sir, is there any real life example for this?
Yeah, we have so many examples. Best example is in your book
None?
itself. Interference of light. They have Thomas Young has explained this. This is the example which they have given in the book. Are you seeing this one? This is interference of light. Okay.
Yes, sir.
This is the experiment we do at higher level, not at this level. And for interference of light, I will give best example for interference of light. You are from Karnataka, right?
Yes, sir.
There is a road from Bangalore to Mysore. Mysore.
Yeah.
Bangalore to Mysore. There is a road which is around 8 long road. Okay. So there were trees next to that means on the side of the road, there were trees, long trees. Okay. And they are close to each other. The problem is whenever a person drives with a speed more than 80, what will happen? He will lose the control over his vehicle and he makes an accident and he dies. People thought there are some evil powers over there. It's not the evil power. Actually, what happened? This is a diffraction pattern. What happens is that the light which is coming from the trunks of the trees like this. These are the trunks, which is coming out from the trunks of the trees. So what happens is it is crossing the diffraction pattern is crossing the brain level. The pattern is exceeding, that is overlapping that one. So he gets a brain hemorrhage and he loses control over the vehicle and he dies. That's a problem. So then when they found out that this diffraction pattern is forming, then immediately they cut out. What was the solution? They cut out one tree from both of them, between each of them. Then the band increased. When the band increased, there was no interference. Even now you can travel on 120 speed. You can study it is on Google also. I am going with a practical experience. Okay.
Yes, sir.
You can study. So people what they thought and on how the scientists investigated this thing. Okay. Now this is one case, and not only that, you are wearing a lens, right? So lens, when they design the lenses, they keep the lens on the screen. If you get it should be a straight lines like this, or you should have like circular ones. This is Newton's rings, what we say. Circular ones. If it is not exactly circular, or if it is not like this type of lines, means there is a defect in the lens. If they are not circular like this, see, if they are like this, means there is some problem in the lens. So they have to polish the lens. So that is why when we buy a polish lens, Ray-Ban and all, we buy Ray-Ban. The cost of Ray-Ban is 800 dirhams, around 400 to 800 or 1000 dirhams also, more than that. But the same copy, first copy, what we say, first copy, second copy, whatever it is, you get for 30 or 40 dirham also, right? Is it not?
Yeah.
We get it in the market. Okay. So like if you go to anywhere, we get for less also. There is a difference. What is the difference? The polishing, the cold wedges. The cold wedges means the lens has a cold wedges. Like suppose this is the surface, but when you see at the microscopic level, there are cold wedges like this. With microscope, when you see there are cold wedges. These cold wedges will spoil your eye. Your number will increase, or you get irritation in the eye. Pain in the eye, redness in the eye. All these things will happen. So that is why whenever you buy a lens, you need to buy a branded one, because the polishing they polish it very well at nanoscale level. So at nanoscale also you will get a smooth curve. That is done using interference, because unless and until you get a line like this or this one, they won't. Then only they will say. That is why on the lenses it will be like tested okay. Tested okay means they have checked all these cold wedges. If the cold wedges are removed, then only it will be passed and it will go ahead for the next level. Got it?
Yes. Sir,
all the lenses in the market, whether it is a convex lens, concave lens, whatever, other than your spectacles, all the lenses will come in the market. First, they are tested properly. Otherwise, there is a aperture or aberration will be there, defect will be there. Okay, so all these things comes into picture. So we have to design the lenses in that way. Got it? The applications now. There are so many applications. As you go on, I will tell you. Okay, as you move on the topic, like best example of interference, your CD player. Did you ever imagine the CD player works on this interference phenomenon? Yeah. CD player or your CD writer or works upon the interference phenomenon. And what is actually basically CD? Yes, CD is actually a mirror with a grooves in it. you know, and it has a wavelength. If they meet when the waves meet in phase, then it will give bit 1. When they meet out of phase, it is 0, 1, 0. So that is how the bits, the digital data is made. When they meet in phase, 1. When they meet out of phase, 0. That is how the data is there. You're all computer students. You understand what is 1, 0, binary digits. All these binary digits, they are read and converted to images. They converted to digital to binary to decimal. Then decimal, it is converted to pictures and all. That is how it is done. Okay. Basically, again, so the one of the applications. There are so many applications. Okay, as we move on, we can discuss many applications. Okay, clear with you all?
Yes, sir.
Yeah. So now, so we will discuss one more case here. One is in phase, one is out of phase. We have discussed. Now we will discuss one more, that is a constant phase difference. If the phase difference is so here, so I'll write a general formula here. The general formula here is what? S1P S1P minus S2P is equal to n lambda. Okay. S1P minus S2P is equal to n lambda, where n is equal to 0, 1, 2, keeps on going. Next is what? S1P minus S2P is equal to what? N plus 1 by 2 lambda.
So this is the same interference?
Yeah, this is in the superposition. When do we get a bright and when do we get a dark? This is constructive for bright. For a bright, the phase difference should be this much. N lambda means 1 lambda, 2 lambda, 3 lambda, anything. But if it is a dark, then it is what? N plus 1 by 2 lambda. 1 plus 1 by 2, 2 plus 1 by 2 means 1 by 2, 3 by 2, 5 by 2 like that. Then when we have this type of the phase difference is this much, then it will get a dark phase. Understood? Is that clear all of you?
Yes, sir.
Now we will go with the next one. Y is equal to A cos omega t, the third one, constant phase difference. Y is equal to again the second one, Y1, Y2, A cos omega t plus phi. So what will happen here? Y is equal to Y1 plus Y2. So Y is equal to what? A cos omega t plus cos omega t plus phi. Okay, cos omega t plus phi. What will happen now? So Y is equal to A cos C plus cos D formula. I am applying cos C plus cos D. What is the formula? 2 cos C plus D by 2. 2 cos C plus D by 2 and cos C minus D by 2. Okay, 2 cos C plus D by 2 and cos C minus D by 2. So here we have Y is equal to what? A into 2 cos C plus D by 2. That is 2 omega t plus phi divided by 2 and cos C minus D by 2. Omega t minus omega t will go away, phi by 2 will be remaining. Okay. So now, so when we solve it now, so it will become Y is equal to 2a cos phi by 2 into cos omega t plus phi by 2. So this whole thing will become constant. That is Y is equal to what? A cos omega t plus phi by 2. A cos Y is equal to what is that? A cos omega t plus phi by 2. A cos omega t plus phi by 2. Okay, so this whole thing is taken where what is A? A is equal to what? 2a cos phi by 2. This whole thing is constant. The whole thing is constant. So we get what is that here now? Y is equal to, we are writing here, A cos omega t plus phi by 2. So therefore, intensity of light. We already know that intensity is proportional to square of the amplitude. The whole thing is amplitude. So what will happen now? I's intensity is equal to 4a square cos square phi by 2. This is the whole amplitude now. Intensity of this. Is that clear all of you? Is this clear?
Yes, sir.
Okay. So once again, even there, this is when it is in phase, when the two waves meet in phase. This is constructive or bright. When they are out of phase, it is destructive or dark. These are the two waves. Y is equal to Y1 plus Y2. Add both of them. Since cos C plus cos D, you get this formula. Solve it now. After solving, we get here Y is equal to 2a cos this one. Y is equal to a cos omega t plus phi by 2. A is 2a cos phi by 2. Intensity is proportional to square of the amplitude. Then we get this one. Please copy this. Then I'll go ahead. See if the phase difference phi is equal to 0 or plus 2 pi or plus 4 pi. In this case, what happens? This gives rise to constructive interference. Constructive interference. If here phi is equal to what? Plus or minus pi, plus or minus 3 pi, plus or minus 5 pi, keeps on going. It gives destructive interference. Destructive interference. Now, the average intensity, see here, we saw two cases. So here it will become what? 4 I naught into cos square pi by 2. So when we solve it, it will become 2 I naught. So this is the average value. Is that clear? Is this clear all of you?
Yes, sir. Yes, sir.
Now I'm writing the definition of interference now. So we have to discuss a Young's double slit experiment. So interference of light he defines like this. Interference of light is defined as it refers to the redistribution of energy. It refers to the redistribution of energy due to superposition of light waves from two coherent sources. Next one, the energy is redistributed. Here, the energy is redistributed, and it varies between that is 4a square and 0. 4a square and 0. Okay. So it refers to the redistribution of energy. This definition is not given in the book actually. They just explain interference and all. So it refers to the redistribution of energy due to superposition of light waves from two coherent sources. And the energy is distributed and redistributed, and it varies between 4a square and 0. So you may ask now, sir, there is a bright and dark fringe. Example. Suppose this is a, here we have a bright, this is a dark fringe, and this is something that this is a bright, white thing is bright. So where did that light go? That whatever the light was there in the dark, that went in bright. Understood? So that is how the law of conservation of energy takes place. Once again, whatever the energy was lost in dark, that went to bright. Got it? Is it clear?
Yes.
So
Yeah.
can you explain again?
Whatever the light was lost in dark will go to the bright. So that is how the light is conserved.
Okay, so
Now, so we have interference of light by Young's double slit experiment. The derivation is deleted, only the concept I am explaining.
Yes, sir. Done.
Done?
so almost done.
Done?
So almost done.
Okay, sure. Going with the interference of light by Young's double slit experiment. Thomas Young, who supported Thomas Young supported wave theory, that is Huygens wave theory. So Thomas Young in 1801, in 1801, okay, interference of light by light waves and Young's experiment. And Young's experiment. Now here, now, so this is the slit. This is the slit. Source is here. All this is in the this one. All they are coaxial. Means the same axis. The center is on the same axis. This is the source, and this is slit S1, S2. This is the slit. Okay, double slit. Young's double slit experiment or Young's experiment. So Thomas Young in 1801, he practically he explained and he proved the interference of light. So this is the source and S1, S2 is the source here. That is slits, double slits, and this is the screen. This is screen, and this distance between slit and screen is capital D. And you know this is in the plane. What is that? So this is YZ plane. Okay. O is the center, P is the point at any point. Now this distance between both the slit is small d. Distance between both of them is small d. This is Young's double slit. At that time there was no glass and all. Now we are doing with so sophisticated instruments, but at that time he took only cardboard. Basically he used cardboard and did this experiment. Now after that he did experimentally, we proved it again with the glass and all. Okay. Now see here there are two sources, S1, S2, and this is the screen. Okay. So this is the screen. Now here D is the distance. Okay, small d is the distance and P is the point. Okay. Now what will happen now? This and this. Okay. So these are the two sources. Here X is the distance from the center. Okay. X is the distance from the center and D is the distance from the slit and the screen. So this screen is G dash. G dash is the screen and Z is the axis. Okay. D is the distance between the slit and the screen. Small d is the distance between two slits. Okay. So we already know that S2P minus S1P is equal to n lambda if it is a bright fringe. N lambda if it is a bright fringe. So we get n, where n is equal to what? N is equal to 0, 1, 2, 3, keeps on going. So now we have, what is that? S2P minus S1P, S2P whole square minus S1P whole square equal to what? D square plus X plus D by 2 whole square minus D square plus X minus D by 2 whole square. Okay, which is equal to what? Why? How come? See here, this whole distance is capital D. We are using Pythagoras theorem. This is X and this is X. Okay, and this one is half of that. Okay, this is D by 2. X plus D by 2. So that is why we wrote X plus D by 2 whole square. Applying Pythagoras theorem, D square plus X plus D by 2 whole square. Similarly, for the next triangle, X minus D by 2. Is that clear? X plus D by 2 and X minus D by 2. When you solve it, it is becoming 2xD. When you solve it, it becomes 2xD. So here what we have now? S1, S2 is equal to D, small d. And we have OP is equal to X. The value of OP is equal to X. So what do we get now? S2P minus S1P. S2P minus S1P is equal to what? Which is equal to 2xD. 2xD divided by S2P plus S1P. S2P plus S1P. Understood? S2P plus. So also X and X comma D is much less than capital. X comma D is much less than capital. Is that clear now? All of you?
Yes, sir.
So this completes your Young's double slit experiment. Okay, once again, there is a source, slit, screen. Distance between two slits is D. It is in millimeters and micrometers, very, very less. And distance between the slit and the screen is 1 meter around. Very big, very huge. So we are small d, this is capital D, this is center, half of that is d by 2, and from the center, the fringe is forming somewhere at point. It can form anywhere. So it forms at the center also, it forms at the other end also. So that is x. So what we are doing, substitute all the values there. When you solve it, you get 2xd. Simplify that, you'll get the answer. Understood?
Yes, sir.
Okay. Copy
Yes,
this. If
sir.
you find it out, ask me please.